Here we have Scott Helme giving his presentation called Crash Burn Report. If you could give him a warm welcome applause.
Thank you. Hopefully that won't be my feedback in the app after this talk. So thank you very much for coming. My name is Scott. You may have seen me. I'm on the Twitters a lot. I talk a lot about information security and various bits of research that I do there. I also blog. I run security headers. You may have seen me from there. And I also have my own little startup called Report Your Eye. Now, I just wanted to start with a little bit of a bit of an outline of what we're going to talk about today, because when I start to talk about new browser features, many people kind of have that little internal sigh where they're like, oh great, there's going to be like bad support, or it's going to be, difficult or not backwards compatible, or there's like all of these really genuine and valid concerns. And the good news is today that what I'm going to talk about, something called the reporting API, is actually really widely supported. Some of the features are only supported kind of, towards the left of this diagram. Some of the features aren't quite supported to the right side of this diagram yet. That was perfectly just, coincidental ordering. There's not like, good to bad, left to right. I'm not saying that. But the really good thing is, as we go through, what you'll see is that it doesn't actually matter. If there is no support or poor support for some of these things, it's not actually a problem. Now, I'm sure like me, many of you have some kind of website online. Could be personal blog, could be corporate website, maybe it's just a little bit of brochureware. Maybe you're actually an e-commerce platform and your website is like really, really important because that's like your actual sales platform. But it doesn't really matter. Like I'm pretty confident to say that all of us have something online. And like me, I do my blog. I have a couple of other services which are a bit more important, but to me, this is really important. And I want people to be able to go online and access it, for this to be a good experience, for there to be no errors, for there to be no problems, be they performance, security, availability, or otherwise. And this is why I put my site there, because I want you to visit it. Now, in order to help me do that, I have lots of different tools that I use, because along comes the visitor, and they're like, hey, I want to go to Scott's website, read his latest article. So off goes their request when they type in my domain, and it lands on the server, running my blogging application, and then hopefully some kind of response will be generated. Now, there's lots of different things that can go wrong at this first step already. My application could be having a really bad day, the server could be overloaded, all kinds of different things can go wrong. And to help me detect that and to monitor that, there are lots of different tools and utilities at my disposal. Just raise your hand. Does anyone either use or use something similar to one of these services? Who has something? So there's loads, like this is basically everyone in the room, right? Because we want to be able to see these errors. We want to have visibility. We probably centralize them. I mean, I'm actually using Papertrail. I've used New Relic quite extensively in the past. So we want to know when things go wrong, and these platforms, these tools, these services will help us do that. That's fantastic. Hopefully nothing goes wrong. We generate the response, we send the response back over to the browser, and you get to read my article, read my blog, purchase your thing on Amazon, whatever it was that you came here to do. But again, there are things that can go wrong on the client side, and for that, there's lots of monitoring solutions that we can use on the client side. Now again, like quick show of hands, either one of these or some equivalent service, who uses something like this on the client side? Well, okay, so that's a lot smaller percentage. That's very usual trend. But the point here is that there are lots of things to help us make sure that things are going according to plan. I want users to come to my site, read my blog. You want users to go to your site and to buy things or to read your blogs. But that doesn't always happen. There are lots of things that can go wrong, and that's why we have so many tools and utilities to help us. But what about this one? This browser has tried to go to my website. Now, this is an intentional error that I've made it make, okay? I've gone to a subdomain on my website that doesn't exist. So if you try to go to this subdomain, there is no DNS entry for it. So it will not resolve, therefore a page will not load, and the browser will throw kind of one of these full-page warning messages that we see here. Now, the really interesting thing here is, let's just say this was my actual site. This was my www.subdomain. There is something that has gone quite wrong, and the user has not been able to come to my website as they intended, as they wanted to. But if we think about all of the monitoring that we just talked about, which one of these things is going to help me here? Right? And we kind of have this gap where if something happens that actually prevents that initial connection, and we're going to talk about all the different things that can go wrong, but there was no DNS lookup, or they did the DNS lookup and the domain didn't resolve. Okay, great, there was no request. But if there's no request, then nothing on the server side can help us, because what's it going to look at? Nothing arrived. If there's no request, there's no response, and nothing on the client side can help us. So now we have like this invisible error from our perspective as the people running the website, where someone's tried to come and visit us and they've not been able to do that, but we don't know that. This is what the reporting API will help us solve. It will help us see these invisible people, these invisible errors, these invisible failures in our infrastructure, our applications, whatever it may be. Because the reporting API allows you to introduce an out-of-band reporting mechanism. So when the communications break down between the browser and our infrastructure, our servers, wherever that might be, and these two things cease to exist, the browser can now send that telemetry, that reporting information, out of band. And incidentally, full transparency, one of the services that I run is designed to ingest this data. Because if you think about this, if you can't make a connection to the host, we can't send the telemetry to the same location. It has to go external, because I can't connect to the host that I was trying to connect to. So we have to have some kind of third party, and that can be a third party infrastructure that you also own, but it has to be third party. It has to be out of band to the failed connection on the way in. Now this sounds really good. It's like, okay, great, I can learn about all of these invisible errors that I couldn't see previously, all these failure cases. Now, to turn on the reporting API, this is pretty simple. First of all, the first step of the configuration is to add the report to header here. Now, these are HTTP response headers. You're probably familiar with most of the ones up there. If you want to indicate to the browser that I would like you to send me this telemetry, this is how you configure it. There is no code to deploy, there's no agent, there's nothing like that that you have to do. This is built-in native functionality in the browser, and you're essentially just kind of hooking that. So this is a really simple deployment. And all you have to do is put the configuration. You can see the report to header is JSON, so we'll just open that out, and you can see what you would put inside this header. So you have to create a reporting group. So you can see here on the first line, my group, I've just called it default. You can call it whatever you wish. So I have a group called default. The next one, the max age, this is the number of seconds that the browser should cache and remember this setting for. And this is kind of where a little bit of the magic happens, because you connect to my website now, everything's working, but you connect tomorrow and it fails. The browser obviously has to remember what to do when it fails. So this is kind of the key part here. Max age, the number of seconds the browser should enable and cache this policy for and apply it. Endpoints, we then pass in an array of locations where you can send reports to. So again, as I just mentioned, I have a little demo account on report URI, and I'm just saying when something goes wrong, this is where you should send the telemetry. You can, again, put any URL that you would like in here, and inside this array, you can actually have multiple, and the browser will even do fallback. So if we try to dispatch it to the first endpoint and it fails, we'll fall back to the second to make sure that you definitely get this piece of telemetry. And then the last one includes subdomains. This is hopefully fairly self-explanatory. If you turn this on, then I want you to send me the following information about not just the domain that you're on, but all subdomains underneath it as well. So maybe you've got like test subdomains, dev subdomains. This would incorporate all of those, and you would receive the telemetry for them. Now, enabling the reporting API, this is just to tell the browser where to send the information when something goes wrong. The something that goes wrong is what you then need to subscribe to. So what things do you want to know about when they go wrong? So this is how and where to send stuff. Next, we need to think, what stuff do we want the browser to send? So the first one that we're going to look at is something called network error logging. Now, NEL, as we kind of like casually refer to it, this is one of my favorite features that uses the reporting API, because the information that you can get back from NEL is something that I just can't see how we would get otherwise. So to fix the error that I showed you on my blog just a moment ago, NEL will send you all kinds of reports about various DNS failures. These are just some of the error codes that we're going to look at. What if the client can't reach your DNS resolver? What if the name isn't resolved, the lookup failed, or some other thing went wrong at DNS? Because if all of your visitors are trying to get to your website and your DNS isn't resolving, then unless you notice that, for some reason you have slightly lower traffic, you're not going to really receive any information about that. NEL will tell you about various DNS failure states. Okay, the DNS lookup works. Client's got to go to the next step of the connection. Then we're talking about TCP. Well, it turns out there's a whole load of things that can go wrong at TCP as well. The connection failed, it was reset, the server refused it. The client can fail again at the point of TCP and then still send you a report about one of these specific incidents, if you will. Okay, TCP connection works. What comes after TCP for most websites nowadays? TLS. We've got to establish the HTTPS connection, the secure connection. And there's a whole heap of stuff that can go wrong here, and this is one of the most common things that we see. More specifically, was the fact that the certificate is invalid because it's expired. So again, the browser comes along, you're serving the wrong certificate, it's expired, you've somehow misconfigured it, but there are lots of different things that can go wrong at TLS because it's a complicated thing to deploy and to keep right on an ongoing basis. But again, if the browser fails to connect at this point, you still wouldn't get telemetry from any of those other systems. But now the browser will dispatch it straight to you. And of course, in all circumstances, if the connection goes well and does, then we can get up to the application layer. But there are still things that can go wrong there as well. So with network error logging, and this is just one of the things that we're going to look at, there's a whole heap of information that the browser will send to you. And if you want any of this information, then all you need to do is indicate to the browser that, yes, I would like this information, and I would like you to send it to me. Now again, super simple to do this, because if you get one of these on your site, and we've got here like a fairly kind of typical certificate. Who's seen one of these, by the way? Everyone has seen one of these. Usually it's because you're in like an airport or a train station and they're trying to force you to log into the Wi-Fi. Most often it's because the site has forgot to renew their cert and some bad things have happened. If the browser sees one of these, you want to know about it. Tell the browser that you want the information, and all you have to do is issue another header. So we had the reporting API header earlier, report to. That says where to send the information. The network error logging header says, okay, I want you to send it to the report to endpoint called default. Remember earlier, the group had the name default. So you're basically saying, if anything goes wrong with this particular set of errors, I'd like you to send it to that group, and I'd like you to remember my preference for, that's approximately a year in seconds. So again, if the browser comes to my website today, it will cache this policy, and next Tuesday, you come to my website, my certificate's expired, and the browser will say, I remember Scott wants me to send this error report over there. And I'll get these errors. And I want these errors because they're really useful. So to take a look at kind of a common example, this is the JSON payload that will be sent. So for every single one of these errors that we're going to talk about, you get a really nicely formatted JSON payload sent as a HTTP post request to the specified endpoint. So this isn't, particularly difficult stuff. The age, if the browser can't connect to the endpoint, it will cache the report and try and send it later. So age will tell you how long ago this problem happened. So if this is 1 hour, this problem happened 1 hour ago, it's just taken a while to dispatch the report. Type, this was a network error. Where was the user trying to go? Here's the URL, then the actual body itself. So you can see here, these are all kind of the fairly simple things that you would expect to see. Sampling fraction, if you want to slow down the volume of reports, this is really handy for that. The values there refer a server IP are blank because the connection failed. It was a GET request. Elapsed time, it took the client 92 milliseconds to arrive at this failure. This is all the information that you need to act on the problem, because the type down here is kind of the ultimate one. TLS error, because of the certificate, because the date was invalid. You're using an expired certificate in production, and this happens a lot. This happens an awful lot. So, when do you normally find out about this? If you have an expired certificate in production, what's your usual channel for finding out? Because it happens, and it happens to a lot of organizations, not just small organizations either. It can happen to quite big organizations. Certificates expiring in production is not, some edge case scenario. It turns out that it happens quite a lot. And the usual reporting mechanism for this is Twitter, right? You open up Twitter and it's like, hey, we've got loads of tweets, and this was actually a LinkedIn certificate. It was all of their country domains. So for my particular one here, it was like the UK dot subdomain, and all of their country level certificates had expired. And you do usually find out about this on Twitter, and it's a very fast alerting mechanism. Now, interestingly, sometimes, it happens to financial institutions as well. This is a large bank in the UK called Barclays. It was for their home insurance department. And incidentally, I love the help down at the bottom here. It's like, could you please try using a different browser? Like, that's going to fix the problem. It's like, oh, the cert's expired. Use Firefox and you can go back to yesterday. I don't know what they were hoping for there. But, I'm not just saying that this is a big problem because it seems to be. I'm saying this is a big problem because I have the data to back this up. One of the other projects that I run is a crawler, and I have this crawler fleet. I crawl the top 1 million websites in the world every day and analyze like whole bunches of stuff about their security. It punches out these raw data files every single day that you can go look at, and it produces lists of, the first one here is a list of sites whose certificates are currently expired in production. So you can grab one of those websites, go to it, and it will have an expired cert. The next one is sites whose certificate expires 1 day or less from when the crawler looked at it. So if you're viewing this like 12 hours after the crawler produced it, chances are like half of them have already gone down. And I actually did this talk not so long ago in Norway, and someone asked to look at one of the files, and I found like, oh, hey, there's a .no, a Norwegian domain on the 1-day list, and it's like, wow, they've got like 38 minutes to go, and I opened the website at the end of my talk, and they were down. So it happens a lot. The 3 and 7-day ones are as you would expect. So don't, Nell is not going to catch this before the error happens. Network error logging basically tells you when all else has failed. This is your last line of defense. This is not preventative, but this is the worst has happened and we need to know about it. As soon as that first user hits that first error, you'll get the report. So you can know about it earlier, sooner, and respond better. But it's not just network error logging either. There's a whole bunch of stuff that the browser can tell you about. So we've covered network error logging. Let's take a look at the next option over, which is something called deprecation reports. Now, deprecation reports are really handy, and I have an example of where they would have saved an awful lot of organizations. Now, this is a supermarket in the UK. They're a fairly big one. I think like the second, third biggest in the country. This is Sainsbury's, and like many different websites, they have a store locator. You go to the store locator, you hit the little GPS button up here, it will geolocate your phone or your device, and then it will give you route guidance to the nearest store. This is a useful feature. I've used this once or twice, especially when I've been traveling in different cities. All of these stopped working. One day, a few years ago, they all just ceased to function. You would go here, you would press the little GPS button, and nothing happened. Can anyone tell me why this would not work? Why this no longer works? Why it stopped working? Louder, sorry? It's more related to something that you can see on this screen, more specifically. We're using the geolocation API. Look at the address bar. The geolocation API requires HTTPS. Correct. The geolocation does now require HTTPS. Because the browser vendors looked at this and they were like, well, we're sending these as GPS coordinates down to like 6 decimal places, which is like this fairly personal information, right? Like who stood in this square? Well, that's Scott, because like he's the only person in that square. So it's fairly sensitive data, and quite rightly they said, look, we're going to disable the geolocation API and HTTP because we don't want users sending sensitive data in clear. Now, Google wrote this on their blog, and Firefox wrote it on their blog. Put your hands up if you read the Google or Firefox developer blogs. 2 people. So how are you supposed to know that they were going to turn off this thing that your production website depends on? Because apparently the answer is like you're supposed to read the blogs for all the browsers and know the things that they're going to do. But this is super difficult. And this is why in the UK, and it was probably the same here, loads of these websites with the functions like this, you'd like just sit there and press a button and nothing would happen. Because they deprecated something that you depend on. If the browser vendor is going to deprecate something that you do depend on, would you like to know about it? And with deprecation reports, the answer is yes, you can if you wish. Because had we had deprecation reporting back then, this is the JSON payload that those websites would have received. You get the same JSON payload format we saw before. The type is now deprecation. What URL did you go to? The body of the report, ID. Okay, we're failing on geolocation. The anticipated removal date of the feature within the browser. Basic little message, geolocation is deprecated over HTTP and will be removed in Chrome 50. The great thing about this is that as soon as the browser vendor has decided they're going to deprecate something, you will start getting the reports. So they could have potentially had these reports months before this feature stopped working on their site. Now, hopefully, like day to day, generally speaking, you should get none of these. Hopefully, like the goal is that we're not using anything that's currently deprecated or soon to be deprecated. However, if you do start receiving reports, like for deprecations, that's something that you literally need to go look at because you're using something that will stop working soon. There's no scenario in which I can't see how this information would not be directly and immediately useful. But it's not just deprecation either. We have something called intervention reports. Does anyone know what a browser intervention is? This is such the wrong term. They're going to come in and does anyone know what a browser intervention is? The browser can choose not to do things that you've asked it to do if it feels that that action is bad for user experience, bad for user performance, or bad for user security. So you may ask the browser to do something, and the browser will look at it and say, on balance, we're not going to do that for one of those 3 reasons. That's what we call an intervention. Now, like I said, reasons can vary. User experience, performance, security. Let's take a look at an intervention report and get a picture of what one of those things might be. So here's an intervention report. Similar JSON format again, type intervention. You went to my website, the ID, audio no gesture, and the message is a request to play audio was blocked because it was not triggered by user activation. Who has been to a website that does this? And is this not super annoying? Like I don't know, I'll tab out to my browser in a minute and I've got like 68 tabs open and one of them starts playing music. And I'm like, tab, 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 tab. Where's the audio icon? Because they're all so small I can't see them. That's super annoying from a user experience perspective. And browsers are starting to pick up on things like that. Auto-playing video is another one of them. So this is purely for the user experience side. Performance. What if the user's on a limited connection, low throughput? Has anyone ever gone to a website and thought, like, why do the fonts look funny today? Go into the console and there will be a message saying, we're using a fallback font because bandwidth is restricted. So the page will load faster if we don't pull in all 87 font files. Because again, the browser is trying to protect the user experience. It won't do certain things. So these are what we call interventions, where you're expecting something to have happened in your browsing experience, but the browser has decided, no, this is not going to happen. So again, generally speaking, you will hope to not get any of these reports. But if you are receiving these reports, then it means that your users are not having the experience that you think that you intend. Now, if that's for security or performance reasons, you probably really want to look at it. User annoyance depends on your view and whether you want to keep trying to autoplay video and make people watch or listen to them. But again, you can ask the browser to tell you. Intervention reports covered. One of the last main ones that we're going to look at is then something called crash reports. So again, all goes through the same reporting API. However, there's only one particular type of crash report that you can get right now, and this is only ever going to be triggered by one browser. So let's take a look at the JSON payload and see if you can tell me which browser is going to send these. Type crash report, went to my website. You get a unique crash ID from the client, which you can go correlate with logs later. And the reason is OOM, out of memory. Which browser might send lots of these? So everyone's like, Chrome. So again, the crash reporting is still quite young, still in its infancy. OOM, out of memory, is the only supported the reason that you're going to get for these at the minute. But again, maybe you have particularly underpowered clients. Maybe your application is doing something crazy stupid that you've missed, and it's just consuming all the RAM. Probably because the user's using Chrome, but like that reason aside, there's something that you can go do about that if you know about it. So all of these reports, all of this information is available to you. All of the functionality that I've just talked about is natively built into the browser. You don't have to deploy some code or an agent or have the user install some extension or thing on their machine. It's built into the browser. And those 2 response headers that we looked at earlier, they're the only 2 things that you need to change. Because basically all you're doing is saying like, hey, send me this information, and this is where you should send it. And that's all that you have to do to get this working. Now, those are the major kind of things that I'm super interested in right now, but there's actually more than this. The browser can send you a lot more information than the ones that we've just looked at. And this is still, by the way, not an exhaustive list. Content security policy is an amazingly powerful feature that allows you to essentially whitelist the sources of content in your application. So you can say to the browser, like, hey, look, when you come to my website, we only load JavaScript from code.jquery.com. We don't load JavaScript from anywhere else. We just load JavaScript from here. And the browser will say, okay, great, like, I know that. Later on, the browser's rendering a page, and they're like, hey, look at this. There's a JavaScript file here from evil.com, and it's like /keylogger.js. Now, the browser, with the prior information that you gave it in content security policy, will be like, well, Scott told me that he's only going to load JavaScript from the jQuery CDN, so I'm not going to load this JavaScript file. Number one, the user is now protected because the evil.com keylogger file is not in my page. And number two, the browser will send me a report and say, hey, Scott, like, I came to your website and you told me all of your JavaScript would come from here, but I've just found this piece of JavaScript from somewhere else, and it will send that to me. So if I receive that report, I'm going to be like, oh my God, like evil.com/keylogger.js, like, I should probably go check this out and see why I have that on my page. It's a hugely powerful mechanism. Not just for scripts, you can do styles, images, fonts, form actions, XHRs, where should we send stuff, not just where should we fetch stuff. You can control every aspect of your application that you want to. Next one over, HPKP. This mechanism's actually currently going through deprecation in Chrome because it was too powerful. It's not often that we say that about a security feature. It was too powerful and it was too difficult for people to deploy. So Chrome and Firefox are the only browsers that support it. Chrome is currently pulling it, which will leave just Firefox behind. But this is an ultra-strong protection if you deploy HTTPS on your website to essentially bind your website to the encryption keys on your servers, such that no one else can ever have a viable option for impersonating your website online. But lots of people configure this wrong because it's very technical, very difficult, and we actually have this thing called HPKP suicide, which is when you deploy this and you deploy it wrong, and then you just brick your website. So this is very controversial. If you're interested, you should read this up just for the controversy. Certificate transparency. Has anyone heard of CT? Okay, everyone that was in my course 2 days ago, put your hands down. So I did a 2-day course just before the conference. It's like an advanced 2-day course on encryption stuff. Certificate transparency is the ability for you to know about every certificate in existence issued to your website, with the idea being that if you look at the list of all the certificates, you should recognize them all, unless someone over here has gone and got a certificate for your website that shouldn't have one. Now, whether or not you know about CT, all of your websites right now must be what we call CT qualified. They must meet the certificate transparency criteria. Now, the vast majority of people in this room didn't raise their hands and they don't know about it, but your websites will be compliant because your certificate authority and the browsers can take care of this. However, that doesn't always go right. Browsers are made by people who aren't perfect. CAs are made by people who aren't perfect. If your website is not CT qualified, the browser will not load it, and they'll get a big red error message in the browser. You can have a report about that. Hey, I'm trying to go to your website and I refuse to load it because you've not met these criteria. Great, I would love to know about that because I need to go fix that problem. Bottom left here, feature policy. Feature policy is a much more recent introduction, but it's one that I'm particularly fond of again because you can control a lot more powerful APIs, including things like geolocation, the camera API, the microphone API. Let's say you have an advert on your website. You got your page, you got like a fairly basic Google ad or whatever it might be down at the bottom. That advert requests microphone permission. The user will get a pop-up in the top left saying, this website would like to use your microphone. That doesn't look particularly good because it's not you requesting it, perhaps it's just the advert. But there are a series of powerful APIs like this in the browser that script on the page can request access to. With feature policy, you can declare which APIs are allowed to be used on your website. So if you go to my website and my blog, you'll see that things like the geolocation API are banned on my website. I say to the browser, look, if you come to my website, I don't need geolocation, so let's turn that feature off, because then it can't be abused. Let's turn off the microphone permission, the camera permission, local storage, all of these things that we don't need. Let's just turn them off because we don't need them. Then if something comes along and tries to request that, let's say I have that advert and it tries to request the microphone, the browser will send me a report and say, Scott, you told me that you weren't going to use the microphone on your website, so I've blocked this attempt, and I'm also going to tell you and let you know. So I can know that there is something on my website trying to access powerful features like the microphone for users that visited my site. So this is a fantastic kind of attack reduction mechanism. You can reduce the attack surface by taking those powerful features away And maybe it's one of your developers. Maybe it's like, hey, we've deployed this new thing into production, and we don't want some developer to start like sucking down geolocation data from the browser from our clients, because in the UK, like, we have this GDPR thing. So like, we have to be super stringent, especially with potentially personal data like geolocation. Next one over, cross-site scripting auditor. Who knows what the XSS auditor is? Is anyone familiar with the auditor? Again, like 2 or 3 people. This is a fascinating thing because this is built into Chromium, so things like Chrome and all of the browsers like that. Cross-site scripting attack would be the keylogger example that I gave just a few minutes ago. Someone gets a script tag in your page and loads in that keylogger. Maybe it's an advert, maybe someone's left a comment, a review section on your website, best site ever, and we pasted a script tag, goes onto the page, loads the script. That would be a cross-site scripting attack. Now the auditor in Chrome, and like soon Edge as well, will try and detect attacks similar to that. If the browser can look at the page and say, we think there's a reasonable chance that this user is currently under attack, the browser will take steps to mitigate that. It may remove the script from the page. It may even just refuse to load the page and say, look, there's something on this page that we really don't think that you should go see. This is on by default in Chrome. If this is happening on your site, your user is already seeing those big warning messages. If you enable the reporting mechanism, you can have the browser send you that, and it will actually send you the attack payload. That's really cool, because you actually get the hostile JavaScript that Chrome thinks is trying to attack your user as well. Now, whether or not you want that, it doesn't matter. This is there, and it's turned on by default. All you're doing here is subscribing to receive the information back. Now, for me, that's kind of like a no-brainer, because this thing may already be happening, and you don't know about it. So all we're changing here is the fact that you will know about it. And then the last one down on the bottom right here, OCSP expect staple. OCSP stapling is a really great performance feature that every website should have turned on, because if you're using HTTPS, this can help you make things go faster. The Online Certificate Status Protocol, if you'd like to do some further reading on that. But again, you may turn on this performance and privacy protecting feature and think, great, like, we should have this on for these 2 particularly great reasons. What if you have it misconfigured? What if you have it broken? What if you have it not switched on one day? The browser will tell you, and this is the thing with the browser nowadays, it's not just a portal to which we send HTML and the user looks at it. That's kind of the old view of a browser. It's like, yep, there's some HTML, let the user show it, and come back later and do something. The browser is now a very active participant in the delivery of a secure browsing experience. If you ask it to help you and ask it to give you this information, it will do. Every single thing on here and on the previous slide, and all of the ones that I've not had time to talk about, they're all native browser functionality. They're all built in, and all you have to do is ask for this information from the browser. Thank you very much. So I left just a couple of minutes before lunch for questions. First of all, are there any before I start on my spiel? If you do wish to leave, please do. I won't be offended. I will take some questions now, though. Yes?
Just wondering how old that, what was the header called? The reporting one?
The reporting API one? So the reporting API, it was sometime in September last year when the first version of Chrome with support came out. So like 7 months-ish, 8 months now.
Okay, that's cool. So that kind of led on to my second question, which was going to be tracking down old clients that are incapable of doing newer versions of TLS, but they're not going to have that header anyway.
Yeah, so we kind of, coming back to the old client thing there, and this kind of ties into one of the points that I made about not worrying about support too much. For pretty much most of the errors there, we actually don't need all of our clients to tell us we have a problem. If only 1% of our clients tell us we have a problem, we know we have the problem. So in most scenarios, it's actually like, well, if everyone here can see my website is broken and just you 3 people tell me, I've still kind of learned the thing that I need. So for the vast majority of these, we don't need 100% support. We don't need, it's like Edge and Safari don't support this yet. Well, that's great, but as long as Chrome users tell us our website is screwed, then I'm okay with that. Any more questions? Right at the back. Do you feel brave to shout, or do you want to wait for the mic? You're going to wait for the mic, cool. That's all right. I'll put you on the spot.
How do you go with false positives? And do you get a lot? Like, if I whip out do you handle false positives.scotthelm.co.uk and refresh a bunch of times? Do you get spammed a lot?
So I'll try and answer the question that I think you're asking, and just to talk about Report UI a little bit. So as a service provider, like as a website operator, I don't really try and deal with the false positives, but that's kind of one of the purposes that I built Report UI for, in that we will handle false positives for our clients. So, you know, this is just JSON ingestion, and everyone is welcome to, like, you know, go spin up an Elk stack in AWS and just like suck all this data in. But there is always like little quirky things happening on the internet, and you do get like this baseline level of noise and false positives. So you do kind of have to refine that data a little bit. But that's one of the things that we were really trying to focus on was, you know, how to just end up with the truly essential reports. But we're, just to put that in context, we're doing about 18.6 billion reports a month for our customers at the minute. So we're basing our false positive detection on like a fairly big pool of data every month. Any more questions? No, if there are, come find me now, come find me at lunch. I'm here for the rest of the event, and thank you very much.